All right, sound check, section 24.7. Okay, we're going to pick up today with section 24.7, the Hofmann Elimination reaction. In the Hofmann Elimination reaction, we start with primary amines. Okay, now remember, this is a primary amine, even though this carbon is secondary because there's only one alkyl substituent on the amine. Remember, the designation primary, secondary, and tertiary amines have to do with the number of carbons attached to the nitrogen. Now, we saw that exhaustive methylation or exhaustive alkylation was the useful reaction we could do with amines, and Hoffman took great advantage of that. If you react the amine with an excess of methyl iodide, you produce the quaternary ammonium salt here. So you quaternize the amine, we would say. Now, of course, since we're making the methyl iodide, the counterion here is iodide. If you react that with silver oxide in water, the silver precipitates the iodide and you're left with an oxide or hydroxide. It really makes hydroxide eventually there, which is then acting as a base to cause the elimination of either one of these sets of hydrogens. Now, the unique thing about the Hofmann elimination is that it gives the anti-Zaitsev product. The anti-Zaitsev product. So the major product will be the alkene that comes from elimination of the least substituted carbon, producing the least substituted alkene. I'll show you a specific example in a moment. Now, the way this works is that in the aqueous silver oxide conditions, the iodide is exchanged for hydroxide, and the hydroxide then does an E2 type elimination. So the other product here, of course, is trimethylamine. Okay, so again we see where we have a stable compound that makes a good leaving group, the way we saw the elimination of water early on in this course. So taking a specific example now, your book has a beautiful one there. They take this pentylamine, the example of this pentylamine, they react it first with excess methyl iodide followed by silver oxide in water, and you heat it up, and in fact you get two products. The less substituted and the more substituted alkene. These are produced in a 94:6 ratio. All right, so that's section 24.7, the Hofmann elimination.